Okay, so
Shall I?
how have you? Yeah. Please
So,
continue.
yeah, so these are like spikes kind of obstacles. So I want to like
Mm-hmm.
give them the material. So if I just drag and drop here, it just doesn't work. It's just
Yeah,
something like that.
because so basically that obstacle, the OBS object that you have, that is a parent object. So can you
So,
open it up?
yes, so there are two of
So,
lower and the roof. So the thing is, if I
yeah.
want to give them, so I have to like individually get each one of
No,
these
no, no.
spike or
What
color.
you can do is basically click on core and then press shift and
Yes,
then click on cone 9. Right now you can drag and drop it there.
still showing that error.
Okay. Can you open this
So I can
CBS,
only
like double click on the OBS game
yes, so
object?
double click.
Double
It's
click.
inside the room, so it just got zoomed out.
No, sorry, not double click. Like, can you open the prefab? Like,
Okay.
go to the prefab and double click on the prefab where it is. Open the prefab. Yeah. Now in this, click on phone and phone 9, from phone to phone 9. Now try it.
I drop it here. Sir, I made this with Pro Builder, so is that a problem?
No, not really. So
Just isn't here.
basically, what you can do is like the cones that you have, are they also like prefabs, or uh,
So they are individual
they
cones
are
and it
individual cones?
is
So I think a better way of doing this would be to make the cones prefabs and
it's
then like just duplicate the cones, right? Once you have added the material. So like that would be the better way to do it. But I guess this is also possible. I'll look into it. This should be working, but I'll let you know about this as well. But that would be a better way, that basically make a prefab of the cone, and then so that you can basically change whatever you want in that in a single cone and then apply it to
so,
all the things.
yes, sir.
Because this method also, you are basically just giving the different cones the same material. Even if this works, selecting all and applying the material, in this case you still have different objects, not a single object, which is basically replicating itself. So better way to do this would be to create prefabs and duplicate those prefabs.
So, thank you, sir.
Anything else that you want to ask?
Yes, sir, that's it.
Okay. What about others? Anupam, Arun, Ayushi. Anyone else? Any doubts or any anything that you want to show to the rest of us? Not necessarily doubts. If you've built something till now, even if you've just replicated what we have built, if you want to show that. Yeah, Dinesh.
Sir, that I forgot that I had another problem that I want like the level one to show that which level I'm playing right now. So
Hmm.
did a I placed an image, white color background
Hmm.
behind the level one text. So the thing is when it's in normally I play it on like the smaller play window, it's fine. But when I full screen it,
Hmm.
so every lot of space is showing me the game. I want the background to be all around the screen. How can I do that? Maybe I should share my screen once again.
Yeah. Can you share the screen and then?
Yes, so, yes. So like when it's here, In the smaller window, it just works fine. Like level 1, if I normally play it, it's working fine.
Okay.
But when I full screen it or resize the screen, so the level 1 background is just small,
Okay.
not covering the
So
entire
I
screen.
I think we discussed something called as canvas scaler in the last session or the last to last session. So can you go back to,
Yes, sir.
yeah, can you reduce the screen size and can you go to canvas?
Yes, sir.
So in this you have this just canvas, not this canvas one.
Canvas.
Parent, you have this canvas scaler, right? So what you'll have to do is basically UI scale mode, change that to uh, scale with screen size. So in the
This
canvas
one.
scaler, yeah, in here, so you have rect transform, you have canvas, you
Yes,
have
sir.
canvas scaler, the third
Yes,
component that is there, canvas scaler. So
sir.
in UI scale mode, change it to
Scale it with
uh,
screen size.
scale it with screen size. And then in the reference pixels, reference resolution, give the resolution that you currently have in your game view. So like go to free aspect. In this, there is game and then there is free aspect, right? So select, go to
Where
that, go to the
uh,
game view.
game view. Yes, sir.
Yeah, yeah. I'm not able to
Free
see your
aspect.
screen. Yeah, yeah. Click on free aspect.
Yes, sir.
Then select a specific resolution from
Resolution.
here. Let's say select full HD 1920 cross
Yes, sir.
1080 and give that resolution here as reference resolution 1920 cross 1080.
Still small.
And yeah, so basically now what you'll need to do is in make the image match this full screen when you want, when you whatever you're doing right now. And whenever you change the screen size, like let's say your reference resolution change, like not reference resolution, your resolution changes to 2048 or 1530, something like that. Then based on whatever resolution you have right now, your screen size or whatever is there inside the canvas, it will scale according to the screen size. So it will play around with it, and then when you like basically change it to match this reference resolution, then what when you play, just try to reduce the size of your screen or increase the size of your screen, and then see how it works.
Thank you.
Okay, and in this also one more thing that you can do is when you are checking on this scale with screen size, there's also a match either width or height, right? So screen
So,
match mode, you can make it match width or height, and in the match, you can make it 0.5 instead of 0 or 1. So basically, that will try to match it with both height and width instead of just one direction.
thank you, sir.
Anyone else still wants to go? We still have 2 minutes. We've kept 20 minutes for this today. Okay. So I guess we'll start today's session. My screen is visible, right?
Yes, sir.
So yeah, so we basically today is the sixth session, and we have already completed one game which is like the very basic, most basic thing that you can build in Unity with. And we have learned some of the basic things till now, like how to move a player with like on a flat surface, how different ways that you can move a player, how to apply force to an object, some basic physics, what are rigid bodies, what are collisions, some of the basic things like this we have learned. And basically, we have learned what gameplay mechanics, like where do gameplay mechanics start with, what are the very basics of how games are built, what are the things that go in building games, like a player, some obstacles, some objective, some rules. So these are all the gameplay mechanics that are there. And in the rollerball object, we had a player, we had an objective that was to collect the obstacles. Rules were basically like we didn't have any rules, just rules were that you collect all the objects and then that is when you win. So we have a win condition. So there was no lose condition in the game that we have created now. So, but you can build upon that and create more things in that game. So today session we'll learn a few more small things. So which are basically which some of the things we have already seen, some of the things we'll talk about more in upcoming sessions. But to start with, we'll see some of the smaller things and how to uh, do these things more efficiently and like basically learn more things on top of what we have already learned and how to include those things in what we are doing. So we'll look at PlayerPrefs, something called as PlayerPrefs, which is an interesting thing which we'll see today, which we have not discussed before today. We have discussed scene management, but but that was only for reloading a scene. We'll look at how scene management works when we want to change from one scene to another and things like that. We've already talked about prefabs, but we'll talk more on that and we'll see how to dynamically instantiate prefabs. So instantiate is basically a function to dynamically or basically spawn or create game objects at runtime. Then we'll talk a bit about procedural generation and we'll look at the very most basic thing of how procedural generation works and what is the most basic concept that you can apply to procedural generation. So uh, let's start. So basically, I have created this GitHub for you guys and I've shared it with you on the uh, WhatsApp group. It's public code repo, and this is the code that I'll start working on with today. And basically, it's the same thing that we have been working on till now. Just removed a few things that we didn't were not using or had not used till now. So this is where we are at. I, this. So this is what we had till now. This is what we have built, and let's today start with uh, PlayerPrefs, right? So let's see what PlayerPrefs are first, according to Unity. So PlayerPrefs is a class that stores player preferences between game sessions. It can store string, float, and integer values into the user's platform registers. So basically, PlayerPrefs is a class, or you can think of it as something that is basically storing some form of some very basic form of data like string, float, or integer. It can only store three kinds of values: string, float, and integer, while basically you are moving from one scene to another inside a game. So let's say and this is what we'll try and implement today. So you start your game and you want the player to enter their name. So the player enters their name when you start the game. And once you start it and you click on something like start button or play button, the player moves on to the next scene. So in the next scene, what you want to show is welcome player name. So this is the most basic thing that you can do with PlayerPrefs. Another thing that you can do is, let's say your player completes this game and you want to, there's some 3, 4 different types of scores, like let's say number of enemies killed or time taken to play, number of bullets used, and you want to take this and either store it somewhere in a CSV file or something, or just basically display this whole thing at the end. So till the time that you are doing things like which are these small things that you want to just take from one scene to another, you can use PlayerPrefs. So how is it done? Is basically this PlayerPrefs, this whole concept is basically storing this data in the whatever platform you're working on it in that registry. So we have registry on Windows, Mac OS, Linux, Windows, like whatever phones, Android, even WebGL. When we work on WebGL, the browser provides us with some browsers indexed DB API. So basically, there you can store up to 1 MB of data. So basically, here it is mentioning how or where different PlayerPrefs data is stored. So on Mac OS, it is stored here. On Windows, it is stored here. So if you want to look at this specific uh, uh, data that is being stored, you can actually go and check inside this registry. Like if you do regedit on Windows, you can open the registry, right? And you can go and check here. Since I'm on a Windows platform, this is what I can check. So others, whoever is on whatever platform you're using, at least while we are in editor mode, you can check in these. When we have already built it, then you can check in these, right? And then there's some specific things for macOS and whatever. And then there are some methods that are associated with uh, associated with uh, PlayerPrefs, which are basically delete all, delete key. These are things like basically, let's say you want to reset uh, kind of whatever keys that you have used. So basically, PlayerPrefs are key value pairs, like you add in dictionaries or stuff like that. So you create a key and you attach a value to that key. So the same way is how PlayerPrefs works. So basically, let's say you create a key called as username, and when you are entering the username in the first scene or in the login scene, there basically you what you do is attach some value. Like let's say I enter my name Vishal, it has this value, string value to uh, a key which is username. So like let's say next time I open this up, I want to start fresh. I want to delete all the values that are there. So that is where I can use delete all. Delete all will just remove all the values, all prefab values. Delete key will remove a specific key. And then we have values like get float, get int, get set, get string, and similarly set float, set int, and set string. So these are setters and getters, which you probably like like they'll set the values or get the values. Very straightforward. And then we have save or hash key. These are some other functions that you can look into, which basically either uh, writes the modified preferences to a disk. So basically, if you modify something, modify a key value, and then you want to save it, then this is how you do it. And if you want to check if there is a key that uh, exists or does not exist, then you can check using has. So these are all the functions that are associated with PlayerPrefs, right? So, like we talked about before, Unity documentation is one of the very best tools or one of the very best places where you can learn things from. So this is all about PlayerPrefs from Unity. So let's try to actually implement this. Let's have a look at how to actually go about implementing the thing that we talked about. Basically, what I'll do is what I want is when I open this scene, I would want to display a welcome username over here. And by like let's first create it here, and then we'll create another scene, which would be our main login screen, where when the person opens the login screen, they'll enter the username, and once they enter the username, they'll be uh, transferred to this scene. All right. So what we'll do is basically we have context. Let's just duplicate this, and what we can do is basically call this name text username text and change its position from there to here is good. And let's add some padding, which is similar to this. Size is 20. And change it to welcome. So this is basically just the player placeholder. Now let's actually create something. we'll just add it in the player itself because this is where all the other text that we are adding is. So we'll add the script to actually display the values. Sorry. So basically, we want to display something here, and now we just what we'll do is use whatever uh, like write a script to display something in this, and what we'll do is we'll write a script to get some value from PlayerPrefs. We have not actually set the value till now, but we can write the code to get the value even if there's nothing there. It doesn't matter. Once we set up the value, we set. So we'll create a new text, public text, to UGUI, and let's call it name text. And basically just in the start function itself, we can just write um, name text dot text equals, we'll say welcome space and then plus. We'll have, so this is how you basically use PlayerPrefs. You'll write PlayerPrefs dot get, and we'll set a string value to get this, and we'll basically write it as uname only. Say it. So this is all that you need to do to basically get this PlayerPrefs value. So now let's see how do we actually set this PlayerPrefs value as well. So for that, what we'll do is but right now if I play this, will just show me welcome because the other text, the other name has not been set yet, right? So this is what we'll see now, how to actually set it. Let's go to scene, we'll create a new scene and let's call it login. Here, let's just add a input field. Let's call it name and let's add a button. Size of this a bit. So this is how basically a input text field is. It has a parent object. Inside that there's a text area. Inside that there's a placeholder text. So we'll change this to enter your name, and we can do it auto size. So basically this, and then that's it for us. Enter your name is fine. And then let's add a button. Sorry, by button, and similar to this, let's make it 300. So basically to move anything in the canvas, Aditi, this was your doubt. So you can basically, when you are here and you are on the this tool, rec tool. So all you can do is basically just click in the center wherever you want to click and just drag and drop there. So let's say we want to keep the button here, or you can change the position here as well. So we'll do -100 just for symmetry. So this is what our normal login screen. We can add text to uh, something here. We can add password, things like that. All those things can be done. But right now we just want to see how PlayerPrefs works. So this is all. And then next, what we'll do is we'll create a new script and we'll call it, uh, let's call it button manager for now. We just want to use it for managing the button right now. Let's move on this. In this, we are going to need um, using TM Pro because we are using TextMesh Pro input field, and we'll use scene management because we want to change the scene when we want to load the new scene. One more thing, let's change the name of this button from button to start button. And change the placeholder text to start. Here we'll create a few variables. So we'll create a string. This is what will basically hold the username. And we'll create a game object which will hold the input field. Let's call it to input field. And then basically in our start method itself, not start method, like any, so we create a method which will basically be called when the button pressed is button is pressed. So we'll call it public. And let's name this button start button. So in this, what we want to do is a few things. We want to give the uname and we want to give it the value as uname if. So this is the game object. In this game object, we'll get the component. We'll get the component tmp underscore input field. And from this, we'll take the text. So this is what we'll take. And then we'll do PlayerPrefs dot set string. Here we'll spread the string this thing. So we have created the, here we are getting uname. So we'll take the same thing here. So basically when you see here, set string PlayerPrefs, first you enter the key value and then the key. First you enter the key and the second argument is the value. So I'll pass the first as key and the second I want to pass uname. That's it. And then let's also do scene manager dot load and the name of our scene, or like we saw last time, we can either enter name of our scene or number. So let's do with number. We'll last time we had 0 as our scene number, so now we'll change that here. Our build settings, we see that we only have this right now still. We can add scenes and we can make login as scene 0. So login is 0 now and rollerball is 1. That is fixed. And then we can add this script to our main camera button manager and give it the username input field. This thing we attach it to our game object that we have created, username input field. And then this button manager will actually come here. We'll create a new click event and we'll give it main camera. In this main camera, we have created button manager and we have created a function called as start button. So now we have everything. So let's see if this works. Give my name. This thing we can change the text size of this as well. So now I am getting welcome Vishal over here, and basically I can play around. And similarly, what I can do is once this whole game is over, I can also store something. Let's say I want to store time, and I'm storing this count value. I also have some obstacles or some other rules in the game. Then I'll store those values and I can transfer that in the next uh, scene, like a game over scene or a game win scene, something like that. So I hope this is clear to everyone. Any doubts in this? Anything that you want to ask? Okay, so this was about PlayerPrefs. What is the second thing that we want to see today? We saw PlayerPrefs, we saw a bit of scene management, right? So obviously there's a lot more to what we're learning. So PlayerPrefs, this is more or less all there is. Scene management, there are a few more things that you can do. Like basically you can we'll learn something like how to actually load, like let's say you have a very heavy environment scene, so you have a whole city environment, very big environment, and then when you click on start it can't instantly load, right? So can you create some animation or some loading screen type of thing, which you see in games, which you see in a lot of games? So how do we do that? So those are things that can be included in scene management, can be done through scene management, and there are additive scenes that can be done through scene management. So like let's say you have one scene where you have created some just the base environment, another scene where the player is moving and all those things. So you can combine these two scenes at runtime using additive scenes. So that is something that can be used in scene management. So these are some things that are a bit advanced, which you look at when you are done with these smaller things. So, but for now, the most basic thing that you should know about scene management is that how to load different scenes. So there are two ways of doing that. One is either giving that a number or passing a actual scene name over here. So just to show this also, I'll just do this. Uh, the name of the scene that we have here is basically rollerball. So if I take this value and instead of doing with number, I pass the string value of the scene, this will still work the exactly same way, right? So, and yeah, so scene management, this is one thing. How to load scenes, there are two ways that you can do it, number and this. And how do you basically see which number what scene is at? You can go to file, field settings, and you can add the scenes over here, or you can switch, basically just drag and drop scenes at top of each other, or like basically drag and change the number that is assigned to that scene to basically make it more like the flow is actually supposed to be. So like right now we know that login is the first screen, so that gets the number 0. Rollerball is the next screen. Let's say we have a game win screen or game lose screen at like next. So that can be number 2. So similarly, like whatever your flow is best, that is how you add screens at the next level. So that's all about scene management for now. Next, let's talk about a bit about prefabs, and let's look at instantiate. So here, so this is again Unity manual on prefabs. Uh, Unity, like we've talked about prefabs, basically prefabs allows us to create, configure, and store a game object completely with all of its components, property values, and child game object as a reusable asset. So the concept of prefabs is that basically it allows us to store a game object with everything that it has and allows us to use it as a reusable asset. So wherever like we just saw an example like he was using cones as obstacles. So wherever you want to make similar uh, objects, multiple of those similar objects. So you want to use a reusable asset, make it a prefab, so that when whatever changes you make in one asset, you're able to reflect it in all the assets. So the prefab asset acts as a template from which you can create new prefab instances in the scene. So like there are like you can read this whole thing on your own. There are some common examples that are mentioned here when we use where we like to use prefabs. So environmental assets, for example, a certain type of tree used multiple times around a level. So this is an actual example of a prefab that you will most commonly use when creating a terrain in Unity or painting a terrain, like we talked about last time. When we were painting terrains, there's an example to paint trees. So for there, when you paint trees, you basically add a prefab of the trees to the painter, and then you can paint those trees. Then there are non-playing characters, which are NPCs. So whatever you want, like let's say you're creating a first-person shooter game, and some enemy has to come towards you when you cross a certain distance or something whatever. But similarly, like you only have, let's say, one asset of military enemy, so you want to reuse that same asset again and again, or like mix and match some assets, different assets, but again, like you want to have similar assets, just instantiate based on some conditions, so you can use prefabs there. Projectiles is one of the most common usage of prefabs. Basically, like let's say you have a gun and you want to fire some projectiles. Guns, generally we use some other concept like raycasting, but projectiles can be used in guns as well. They've mentioned the example of a pirate's cannon, because cannon is like a slow projectiles, and you can actually see a projectile go. So that is one of the good examples, and we'll see how projectiles are made and what you can do. And that's it. So basically, and player's main character is also an example where it's basically if you have different scenes, you want to create the same player at the starting point on each level. So this is how you can do it by creating a prefab of your player as well. So this is we have talked about prefab. This is again a recap of the prefabs that we have looked at till now. Now we look at how to instantiate those prefabs. So we have created, and we know that there's a lot more to prefabs, which are here: nested prefabs, prefab variants. But these are things that you will eventually learn about on your own. These are not things that generally we need to go in at right now. And we know how to create prefabs. The easiest way is to basically just go here, drag and drop it into the prefabs folder. Like we have created this collectible item. Uh, in this scene, we have this collectible prefab. So we have these prefabs which we uh, set up over here. So now what we'll do is basically instead of setting it up like this, like we have set up, uh, actually physically doing it, physically in the sense actually manually doing it, what we'll do now is write a code to randomly spread 10 collectibles around the environment and not do this like this, right? So let's see how we can do that. So there is something called as object instantiate, right? Uh, and how do we instantiate an object? Basically, what does this mean? So instantiate basically means is to spawn an object or create an object from some reference object. So we need an original reference object, and there are different methods that are here that you can use. So like if you just want to instantiate it, this will basically instantiate it at 000 location, right? Or if you want to give it a specific parent, then you can give it a parent. If you want to give it instantiate it in world space, then you can use either true or false based on if you're giving it a parent. Do you still want to instantiate the location to the world space, or do you want to instantiate the location to the parent's location? So this is something that you can use. In this thing, I said 000, it will not instantiate at exactly at 000. It will instantiate at whatever the original object's position is. Like whenever I have a prefab here, like let's say I have a collectible, this prefab here has 0, 0.5, and 0 location. So when I instantiate, this is where it will instantiate. If I change this position to someplace else, then that is where it will instantiate in case I don't give any thing, any position. So, but I can also give a position. So I can have instantiate original and position and then rotation. And I can also basically include this. I can give a position and rotation, and then I can also include a parent in this whole equation as well. So this is like the full, which includes everything. I have a original object. I can give it a position. I can define a rotation, and then I can define a parent under which it should be. So this is again a lot of descriptions and everything. Examples are all given here. You can look into this, but let's just see how this works and what we are able to do with it, right? So let's go over to our Unity scene, and what we'll do is so and our player is a bit not in the center. Let's make it a bit centered. That's fine. Now let's see. So now we'll create a new script, and let's call the script spawner, and we are spawning collectibles. So let's call it collectible spawner. So in this, let's create a few game objects where we actually want to store our prefab. So this will be our collectible prefab v1 game object. And one would be collectible parent. And then we'll create the start function. So we want to basically uh, instantiate all the prefabs in the start function itself. So start function, because we want it to load with all the prefabs loaded, right? So let's use the instantiate function now. So instantiate, and let's start with just collectible prefab. So let's have a look at what happens when we just use this, just use the collectible prefab and nothing else. Collectible parent, let's attach the script to this only, and collectible prefab would be our prefab collectible, and our parent would be collectible parent itself. See what happens when we play. Seems wrong. Oh, we do have a clone here, but it has been deactivated. Sorry. This is because our collectible is deactivated. Why is this happening? I'm not sure. Let's just delete them for now. And then let's see. Why it's like this. Oh, it's basically, oh, so I forgot that we have this, like it's starting in this location itself. And the concept that we have implemented till now is basically that the player is touching when it's touching the object, then that goes away. So like, let's remove the player for now and see how that's instantiating. So here we have one collectible that's instantiated. So you see that even though we wanted to specify a parent, right now the collectible is basically coming outside as a collectible and in brackets as a clone, right? So now let's see what other function that we can use. What are the other things? So we can basically give it a parent. Uh, so let's do that. Next, we'll give it a parent, collectible parent. So we can't just write collectible parent because collectible parent, what we have defined here is a game object. And in the function that you see, it's basically transform of the parent object. So what we'll do is collectible parent dot transform. And let's see how that works. When we play, it instantiates inside the collectible parent. Now what we want to basically do is we can figure out some way of coding uh, a s- coding a pattern, right? We can figure out a way of making it inside a pattern like a circular pattern or a star pattern or things like that. So we can figure out positions x, y, z positions. X, y, z, y is fixed 0.5, x and z positions coordinates where we want it to instantiate. But right now, let's just randomly instantiate it between like this is -10 and this is 10. This is 10 in the z direction and here somewhere is -10. So let's instantiate all the objects between -8 to 8 somewhere randomly in this environment. So like -8 to 8 in the x as well as the z direction, right? So let's give that, give it the uh, position. So to add position, what we can do is new vector 3, and this is again a new function that you will see, random dot range. So there was an old function called as random range, which is not deprecated. So you can use just range, and the range basically returns a random float within minimum and maximum value that we define. And these both values are inclusive. So let's say I give random dot range, and then I give -8 to 8, and then in my y-axis would be 0.5, and this will throw an error if I don't write f. So whenever I'm writing a float value, I have to write it with f to specify that it is a float. And then again in the z direction, random dot range -8 to 8. But now, like it's still showing an error because I also will have to define a uh, rotation. So the best way to do that is basically quaternion dot identity. So quaternion is basically a variable like, so vector 3 is a variable that stores 3 values. Quaternion is a variable that stores 4 values and is basically used to represent rotations. We can look at this more at a later stage, but for right now, let's just use quaternion dot identity, which is basically just the it will just take the whatever the value of rotation is there uh, in the object that we are loading. So let's save this. Look at the code again. What we are doing, instantiate collectible prefab. So this is our game object that we want to instantiate. Then we have defined a position for this, which is between like in the x and z direction, the position is -8 to 8. And in the y direction, it's at 0.5, which we want. We have defined an identity to basically be the same as uh, uh, 0, 0, 0 in a sense, I guess. I forgot if it will basically use the identity from the transform or basically make it 0, 0, 0. I'll check this, but I think it will be 0, 0, 0. And then basically using the transform of the parent. Save this and let's go back here. Let's see what happens. So now my clone is created at a location of -1, 1, and 0.5. So but I wanted 10 clones to instantiate and not just one. So for doing that, what I'll do is I will put this in a loop. So let's write a for loop and basic simple for loop basically int I equals to 0, and we just want to create 10 and then I plus plus and put this line inside here. That's it. Now we have random collectibles. They are all rotating and everything is basically dynamic. And now let's turn on our player. And then again, right. All the things are still working the same way. So this basically adds a level of dynamicity to our projects that we create or whatever that we create. And basically we are able to create more with this. Like we are not concerned with uh, putting down things like creating, designing the levels. We can create those algorithmically. So this, in a sense, is the start of procedural uh, generation or procedurally creating environments or creating animations, things like that. So whenever you look for procedural generation, you will see that this is where the very basics of it starts. So this is all about prefabs and instantiate and all those things. Doubts in this till now? Okay, so we've talked about prefabs, we've talked about instantiate. Next, we want to talk about procedural generation. So procedural generation, when I say, is basically a method or a way of algorithmically generating or algorithmically creating various things, like various things in the environment or in the animations or whatever basically components that you can create or generate algorithmically rather than manually doing those things is basically comes under procedural generation or procedural methods. So our time is up for today, but next in the next session, this is one of the topics that we'll cover, and then we'll also start with some. We'll also maybe look at some smaller topics. Then we'll start with another building another game, which would be more uh, comprehensive and like maybe take the next step towards creating a game. So that's it from my side for today.